In our last video, we kind of finished talking about separating mixtures by physical means. In this section, we're going to talk about physical change, chemical change, physical properties, and chemical properties. If you didn't read about separating substances by their physical means, make sure you stop this video and go back and look at those before you resume. But let's go on with this, assuming that you did read as I requested you to do. Okay, so we have physical, chemical changes, and physical and chemical properties, which is what this is going to be about. First of all, physical change. In a physical change, you do not alter the composition or the identity of the substance. That is a physical change. So if a change is happening and the substance is not changing its identity or its composition, then that is going to be a physical change. Here's some examples. You take an ice cube, you set it out on the counter, and it melts. You put it in your Coke, and it melts. It is changing states. It is going from the solid state to the liquid state. So you might say, well, isn't that altering its composition? No. Ice and water are both H2O, so the composition has not changed. If I were to take some sugar and put it into water and stir it up and dissolve that sugar, it is still sugar dissolved in water, and I could drive off the water and be left with the sugar. It is still present and its properties of sweetness is not changing, and that is a physical change. If it's not a physical change, then it's a chemical change. And in a chemical change, you're actually altering the identity of that substance. So what it was is no more. It has become something completely different and have different properties and a different identity. So an example of this could be, we could take some hydrogen gas and some oxygen gas and we could light it on fire. And actually it could go boom pretty loud if I had a lot of it. But what it turns into is water. Now the property of hydrogen, the property of oxygen are very, very different than the property of water. The property of water, we know we can drink it, we can swim in it, we can bathe in it, whatever. It's got these very distinctive properties that hydrogen and oxygen don't have. So that would be a description of a chemical change. So anytime you started with one substance and now something completely new has been produced, then that is going to be a chemical change. Now we can talk about, which is very subtle, chemical properties and physical properties. So a physical property is a description. We're describing something and we're examining something, and in the process of doing that examination and describing it, we're not changing the identity of that substance to make that observation. Okay, so what do I mean by that? Here are some examples of physical properties. Odor. Okay, smelling something doesn't make it turn into something different. Taste, color, I've got a red shirt on, and identifying that as red doesn't turn it into something new. Okay, melting point. When I see that an ice cube melts at 0 degrees, I let it melt. I'm not changing the identity of the substance. Boiling point. And we haven't defined density yet, but just kind of make a mental note right now that density is a physical property. The chemical properties are properties where you actually have to undergo a chemical reaction before you can describe that property. So to describe it, you're describing a chemical change. So it's a very subtle difference. What's the difference between a chemical property and a chemical change? Well, the change is the actual change. The property is the description of that change. So we could say that metals corrode, okay? For the metal to corrode or to describe that, we had to observe that the metal turned into something else. So rusting, for example, would be a corrosion of a metal. And when it goes into the rust state, it is nothing like the iron that it started with. Flammability, if something is flammable, we could say, hey, gasoline is flammable. Well, we can describe that, but what we're describing is if you took gasoline and put a match in it, it would catch fire, okay? So it's flammable. If you took a piece of paper and lit it, it would catch fire. So in the course of that description, we are describing that a change can occur, okay? Acidity and toxicity are other examples of chemical properties. So I want to just kind of finish with this little picture here, and I would like you just to think about what you see in this image and pause and ponder and decide whether or not which one of these describes a physical change. Okay, so if you picked picture number 1, you'd be correct. All we're doing is taking those molecules that were really close together and pulling them apart into the gas phase. That's a physical change. If you look down on the molecular level, the picture on the right, we actually see that we're incorporating oxygen atoms, that's what's in red there, into the iron atoms that were yellow. So you ought to, if given scenarios, you should be able to say, hey, what is being described here is a chemical change, or what is being described here is a physical change. So one's a chemical property and one's a physical property.